Hey y'all, just real quick, some of you just left physics, but I wanted to just make sure you were cool on the circular motion problem we did today. I do joke, we really do love to go to Hershey Park each year. It gives us an opportunity for us physics teachers to really highlight and showcase all of the things that we do in the classroom in a real life experience. So being able to go to Hershey Park each year is an awesome opportunity for you guys, because you get a chance to actually experience this normal force that we talk about, or experience 2 G's of force, and get a chance to really experience physics. So the problem that we did today, we were talking about a woman in an airplane and talking about how her normal was in relationship to her weight at the top of the loop. Now, one of the things that happens sometimes when we're doing these problems is we identify that forces are vectors, so they have direction, and we identify that direction on the problem when we do our free body diagram. When we go through and do the math, we're moving things around, and sometimes we get a little confused, and I don't want there to be any confusion. When we did this problem, we determined that the direction of the acceleration was down towards the center. The normal and the weight both are pointing down. So when we set up the equation and do the math, we come up with a positive value for the normal. The normal force is still pointing down. It's still a negative value. Algebraically, though, we moved it over to the other side and it became a positive number, but it's still normal force is pointing down. The way that we know that is if we calculate the net force acting on the system by F equals ma, and we calculate A by using velocity squared over R, right, in our problem. If we calculate the net force, it was 600 something, and it's pointing towards the center of the circle, and in relationship to the plane, that's pointing down. So when we calculate that, it's 600 something, that's the value of it. And that means that when she's going, around the hoop, she's feeling this almost like weightlessness at the hoop as she's flying around it. So don't let this, when you move things around, confuse you. That normal force is still pointing down. It becomes a positive number here because we moved it, but it's still a negative force vector. So hopefully that clarifies anything like that. Please remember, when we're doing these force problems and the question's asking you for what seems to be a pretty straightforward or simple thing, it's not that it's complicated. It just requires that we do all of the work that we do to draw a quantitative force diagram. And then the normal force should be about 6 times shorter, or the weight should be 6 times longer than the normal force in the picture. And that's why we have it drawn that way. I think that's all I wanted to say. I just wanted to talk about this problem a little bit, and not sure if any of you are out there watching, but if you are, have a great weekend, and I'll see you on Monday. Cool. Now for the awkward ending.